Hi everyone, I'm Leann and I'm a Gen AI Developer Advocate at Diffbot. In this session, we'll be talking about GraphRAG, and what you're seeing here on the screen is actually a static representation of a GraphRAG application jointly created by Diffbot and Neo4j. So if you already heard about GraphRAG, you probably learned from a recent project by Microsoft, right? Well, there's some differences in how they constructed GraphRAG and their research versus the applications that you'll be seeing in the session. But the core idea is to integrate knowledge graphs and large language models to improve the performance of RAG system, which in turn leads to higher accuracy, relevance, and explainability in LLM-based outputs. So now I'm going to briefly show you how this application actually works. We can first check the backend, which is supported by Neo4j, and right now we don't have anything in our graph database, and we'll be using Diffbot's API to load data into our RAG system. So what we're trying to do here is to import recent news regarding a company that we're interested in. So for example, if I type NVIDIA and extract and import 20 articles, now we have 20 articles imported. We can further use Diffbot's natural language processing API to extract entities and relationships from all the articles that we have. Now that the extraction process is complete, we can go to the backend and see what we're getting. So right now what you're seeing is the graph of structured information, which includes organizations, location, skills, and text chunks. These text chunks are being split by the articles that we previously imported. And the interesting thing here is that the numerical values of embeddings are being stored as properties under each chunk node. So for those who are already familiar with the mainstream vector-based RAG, we will be relying on these numerical values to do vector similarity search later on. Whether you're viewing the data from the back end or from the front end, this is essentially a knowledge graph that we just created, and information is being connected. So I just walk you through the process of converting raw unstructured text data into a network of structured information. And I guess right now you're probably questioning like, what are we going to use this network of information for? Or what does connected data have anything to do with RAG systems? Right? Well, I think one of the most effective way to answer these questions is actually to show some results. So let's go to the last component of this application, and I'm going to demonstrate one of the obvious difference between RAG system purely based on vector search versus the ones that leverage both vector search and knowledge graphs. So right now you can see in this application, we have different retrieval mode. First, we're going to use vector only, and this retrieval technique leverages both keyword and vector search. It's a hybrid search. And let's ask, who are NVIDIA's competitors? Okay, so here we got AMD, and let's inspect the context data. Okay, so the text here does seem to be related to our question, and we found AMD here. So this is okay, but here we're getting only one answer. The next mode that we're going to try is vector plus KG, which uses keyword and vector search to find relevant text chunks, and also use knowledge graphs to help us identify relationships between information. So I'm going to copy this. So now you can see the two answers that we get from different retrieval techniques are quite different, right? The first one is purely based on vector similarity search, and this one is more structured. And why is that? If we inspect what's being retrieved in the backend again, now you see that relationship-based information is also being considered, such as the partnership, subsidiary. Those are both very long lists. There we go. This is exactly what we see here, right? The structured data that you see here is being included, but also retrieve the unstructured data related to our question. And right now what you're seeing here is pretty much the same from the context data being retrieved in the previous vector-only mode. But what I'm showing here is that the reason why we can get more comprehensive lists of answers to our questions, which are also more accurate than the previous one, is because information is being structured with relationships. And what I'm showing here highlights the nature of knowledge graphs, which are deterministic information connected by relationships, which can also be regarded as a map for LLMs to navigate and better find relevant information. Especially right now, it's still challenging to deal with the non-deterministic nature of LLMs, right? Hallucination is not a bug, but a feature. So let's go back to our slides. And in this session, I aim to address 3 questions. The demo that I show addressed the first one, and now we're moving on to how to build a GraphRAG, especially a good one. So before building a GraphRAG, we actually need to first build a knowledge graph that's good enough, because building quality knowledge graphs is often the hardest part to begin with. So just to recap what knowledge graph is, the TLDR version is that they are interconnected structured data. And creating knowledge graphs has been quite a challenging process because we need a lot of human labor to monitor the process and advanced NLP techniques until LLMs came out. So I guess probably some of you already have experimented building knowledge graphs with LLMs. And to be fair, LLMs have been very incredible at understanding semantically from text data. There's no doubt on how powerful they are. However, there's also caveat when we want to fully rely on LLMs to automate the knowledge graph construction process. So there are challenges for sure. And one of them is they don't seem to be very reliable extracting the correct information every time. As you can see from this piece of output on the right, Microsoft tools should not be considered a valid entity, and Sam Altman is definitely not a product. I think we all agree on that. And there's also another important aspect in creating knowledge graphs, which is entity resolution. Entity resolution means that we should merge the same entities across different text data into a single and unique record. However, LLMs don't seem to be very good at this so far. So the output here is from the same project that I showed previously. I collected 12-ish articles and I asked LLM to create a knowledge graph based on the OpenAI drama that happened last year. So initially, it actually correctly identified Sam Altman as a person, which is great. However, if you go down, you'll see that Altman is being recognized as an organization. Even the context is just a few lines after. And the same also happened to Greg Brockman too. At one point, LM thought he is a person, and this is correct, but later on, it thought it's an organization name. And this signifies an issue that LMs don't seem to memorize correctly or consistently facts. Especially limited context window is also something that we need to handle. So if LLMs cannot consistently memorize and categorize the same information as a single record, the knowledge graph being created will have information that is scattered all over the place. And this will lead to inaccurate retrieval issues. So what are the alternatives? Well, I already showed you in our demo previously that we use something to convert raw text data into quality knowledge graphs. And who's working behind the scene? Is Diffbot's natural language API. So this is the sample text data that I copied from this LinkedIn news. As I submitted, it automatically extracted entities and create a knowledge graph. As you can see here, it will show you the different types of information, the facts, and it can also give you a summary of it. And as I mentioned previously, entity linking is crucial in quality knowledge graphs. So if I click on Chipotle, it would lead me to other facts related to Chipotle, which tells us this is a valid information. This is not something being made up or being hallucinated. You can literally paste any custom text data that you have. The link is included in the slide, so you can play it around. Now we're on to our final question. Which is better, vector-based or graph-based RAG? Well, the answer is it's not an either or question. We need both. And why both? Let's first look at some of the weaknesses if we decide to only use one technique in our RAG system. So the first one is, if we only use vector-based RAG, what are some of the weaknesses? The first challenge is the lack of structured context, because in vector-based system, there are no explicit relationships between entities as we saw in the knowledge graph-based RAG system. And the second is limited explainability. So if you still remember in our demo, in our vector-only mode, when we further inspect the context data, we only get a huge chunk of text, which means how relevant the answer is to our question is entirely determined by language models. We can't always have a clear idea of why this information is being retrieved to answer my question. In contrast, in a graph-based approach, we can more clearly see the information retrieval process because we can see how LLMs navigate information based on relationships. And the third one is it's challenging for vector-based RAG to deal with queries that require sorting, aggregations, or filtering. So here's one example. So this visualization is borrowed from one of the notebooks from Tomasz Batanic. The GitHub repo is included under the slide. So what is visualizing here is the closeness of information. In this example, the question was, what are the 5 articles that have the lowest sentiment scores? And if we mainly rely on vector similarity search, we will get the green dots here, which suggests these 5 green dots are more relevant to answer our question. However, the reality is the exact 5 articles with the lowest sentiment scores are much further away in this embedding space, which means there's a mismatch between what LLMs think are relevant to answer your question and the actual accurate information that should be retrieved. So this is exactly the example of how vector similarity search couldn't necessarily do very well in queries that require sorting. Here's another example where we also found that if we want to find information that's the latest, these type of terms can really be mapped meaningfully in the embedding space. Facing this type of query, we would need to sort the information by dates in a descending manner. And as you can see here, vector similarity search could not really find the correct information with the correct order of the dates. Instead, information that is being interpreted as the latest is being retrieved with the green dots. So this is something that we need to keep in mind and be aware of if we want to build RAG system based on vector similarity search. There's definitely more advanced techniques that are worth exploring to improve the performance of these LLM-based applications. Next, what are the weaknesses if we use only graph-based RAG? It would be challenging to capture some semantic nuances because it doesn't have as much flexibility in finding semantic information as much as in a vector-based system. And the second is because relationships are explicitly defined in the graph database, it would make the retrieval process a little bit too narrow, as some of the long-tail information wouldn't be necessarily considered because the system couldn't capture the semantic meaning. And the third one is related to the inefficiency in retrieval process. So for example, from the GraphRAG research from Microsoft, if you dive into the token cost and the querying time, it's actually very costly, both time-wise and budget-wise. So latency in querying and also the resource-intensive nature of GraphRAG should definitely be considered more carefully if you want to create a more seamless and efficient user experience eventually. Right now, as we walk through the weaknesses, if we combine both vector and graph-based approach in RAG systems, they can complement each other's weaknesses while leveraging their own strengths at the same time. And actually, just a recap, in this GraphRAG application, there's different retrieval techniques that you can play around. And literally what we demonstrated previously is to compare the performance between vector only and vector plus KG. So I'm not leading a conversation to compare vector versus graph. Instead, we think, why not both? So in this session, we can briefly cover what GraphRAG is, its performance and functionality. However, that's not everything about GraphRAG. There's still more to explore. And right now, we're continuously trying to experiment and find out different techniques that can improve the performance of LLM-based systems. And another equally important point is that as we work more and more to build applications with LLMs, we do need to develop some of the custom benchmarks, evaluation techniques to ensure that we can have a reliable LLM system with deterministic outputs if needed. That's pretty much it for this session. We at Diffbot, we are trying to make sure LLM applications can be trusted and reliable. So we'll be continuously making educational content on some of the applications that we we build, what we found to be effective, and what are some of the useful information. So if you want to learn more about applications that leverage both knowledge graph and LMs, feel free to reach out with any questions you have. I hope you enjoy the other sessions at NLP Summit. Thank you.